two or more resistors can be connected in different ways such that we get a desired value of current and potential difference. One of the ways of connecting the resistors is parallel combination of resistors. Here we are going to discuss what is the meaning of parallel combination of resistors. When resistors are connected in such a way that one end of each resistor is connected to a common end and the other end of each resistor is connected to a common end, then we call it as a parallel combination. This is a circuit diagram where there are three resistors connected, R1, R2 and R3 in parallel. Now just concentrate on this part of the circuit. We will see that one end of R1 is going to the point X, the one end of R2 is going to the point X, and one end of R3 is going to the point X. Similarly, one end of R1 is going to the point Y, the other end of R2 is going to point Y, and the other end of R3 is going to point Y. So there are two common ends X and Y where one end of each resistor is being connected. This is what is exactly meant by parallel combination of resistors. Now the remaining is connecting this combination in a circuit diagram wherein you are connecting a battery, a key, an ammeter in series, and there is a voltmeter which is connected exactly across the combination. Now what happens when the battery is connected? You plug in the key, the current begins to flow, and when it reaches the point X, it gets divided into three branches. So a part of the current will go through R1, a part of the current will go through R2, and a part of the current will go through R3 depending on the values of R1 and R2 and R3. Suppose R1 is higher than R2, then it will draw lesser amount of current as compared to R2. So depending on the values of R1, R2 and R3, current gets divided into I1, I2 and I3. So the total current flowing through the circuit is given as I. So mathematically we can write I is equal to I1 plus I2 plus I3. Now if Rp is the equivalent resistance of this combination of resistors, then when you apply the Ohm's law to the entire circuit, we can write it as V is equal to IRP, or I is equal to V upon Rp. So this is one more mathematical expression that you get when you are applying the Ohm's law to entire circuit. Similarly, when now there is a point to be noted, though the current gets divided, the potential difference remains the same across R1, R2 and R3. That means if you connect a small voltmeter across R1, a small voltmeter across R2 and a small voltmeter across R3, you will find that all the three voltmeters and this voltmeter will show the same reading. So it basically means that the potential difference is going to remain the same across R1, R2 and R3. So now when you apply the Ohm's law to the individual resistors R1, R2 and R3, we can get it as V is equal to I1 R1, or you can write it as I1 is equal to V upon R1, I2 is equal to V upon R2 and I3 is equal to V upon R3. So here we have three mathematical expressions. This is the total current, this is applying Ohm's law to the entire circuit, and this is applying Ohm's law to the individual resistors. So now applying the values of 2 and 3 in 1, we get an equation like this: V by Rp is equal to V by R1 plus V by R2 plus V by R3. Now basically if you look at this, taking V common, we will have 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3 because V gets cancelled on both sides. So this is what is the resultant of three resistors which are connected in parallel. So how you can state this is the reciprocal of the equivalent resistance will be equal to the sum of the reciprocal of individual resistances. 1 by Rp is the reciprocal of the equivalent resistance of R1, R2 and R3. 1 by R1 is the reciprocal of R1. So when you add the reciprocals of R1, R2 and R3, what you are going to get is the reciprocal of the equivalent resistance, which we will know that the conclusion drawn from here is the equivalent resistance overall is going to reduce and the current will increase. So if you want the resistance to be decreased, we can say that connect the resistors in parallel. So this is the mathematical expression for the parallel combination of resistors.